2019, number 3. Okay, we're given this function right here, f. It says the continuous function f is defined on the closed interval from -6 to 5, which is interesting because this graph starts at -2. The figure above shows a portion. What does that say? Yeah, a portion of the graph of f consisting of 2 line segments and a quarter circle centered at the point 5, 3. It is known that the point 3, 3 minus rad 5 is on the graph of f. Okay, so first of all, we got to label this bad boy. We know that this is f, but we are only seeing a portion of f. So let's attack letter A first. Letter A says if the integral from -6 to f dx equals 7, so this one says going from -6 all the way to 5, which is interesting because we start at -2 here. It doesn't start at -6. Find the value from -6 to -2. So it looks like we have a missing part right here, and we're going to have to find the value of the area underneath the curve from -6 to -2. Show the work that leads to your answer. So I'm going to go ahead and write this out first. -6 to -2 is what we're looking for. And we know, actually, if, let's see, if I write this out, this is what we're looking for. We know that this one, which goes from -6 all the way to 5, minus this area right here, -2 to 5, that would give us this result. So I'm going to go ahead and write that out. The bigger interval, okay, minus the smaller one, -2 to 5, would give us the -6 to -2. So can we figure this out? Yes, we can. We're given this value, which is 7, and then the other one that we're going to subtract is going to be the area between the curve and the x-axis. And so we have a lot of areas to find. We got to find this one. In order to find that one, you multiply 1/2 times the base times the height. I get 1/2. And then we're going to find the area of that one. Now this is going to be a negative area. So we have to go the area of the base times the height times 1/2. So this is what it's going to look like. Check it out. That's a 1/2 right there. And I figured that out because this line segment right here has a slope of 2. It goes up 2, then right 1. Which means that right in the middle right here, right in the middle of 0 and 1, we would have a 1/2. So we have 1/2 times -1, which is our height, times, that would be 1 and 1/2, which is the length of our base. Now I probably should write 3/2 for that just because this is not a calculator problem. I'm going to have to work with that fraction, so an improper fraction will be easier. Next, we're going to find the area of this triangle. That's 1/2 times the base times the height. There's my 1/2. The base is 1.5, and our height is 3. And then finally, the last one. Now, this one is actually pretty difficult. This one, to find the area of this underneath this curve, I'm going to think of the area of this square right here, and then take out the area of this quarter circle. So we're going to have to find the area of that quarter circle and take that away from the area of the square to find the area underneath the curve right here. So to find the area of the quarter circle, first I got to find the area of the circle, which is pi r squared, and the r is 3. So I go 3 squared times 9, which is 9 pi, and then I'm going to divide it by 4 because we only have a quarter of the circle. Then we find the area of the whole square, which is 3 times 3, which is 9. So we go 9 minus 9 pi over 4. That's going to be the area underneath between the curve and the x-axis. So I'm going to write that right there. And this is gnarly. That's a lot of stuff right there. Now I'm going to simplify it up. Okay, after some arithmetic, elementary school math right here, multiplying numbers together in fractions and adding them together, making sure I don't make any mistakes with negatives. I get 8 minus 9 pi over 4 plus 9. And a little bit more simplifying here, I just distribute that negative. I get -2 minus 8 minus 9 pi over 4. And I'm really confident my answer is right, and I also double-checked. I double-checked the scoring guide. The scoring guide gave me a different answer, so I went ahead and simplified this just to confirm that my answer is right. And when I do simplify it, I divide the 8 by 4, the 9 by 4, I get the answer that the scoring guide says. But if I left my answer like this, I would be fine. I would still get the points. All right, so let's look at B. B says evaluate the integral from 3 to 5 of this mumbo jumbo. Okay, so going from 3 to 5 of this new expression with f prime inside of it, I'm going to have to take the antiderivative of this. So now you should know the basic laws of integration. If you have an addition sign in there, it's the same as taking the integral of just this plus the integral of just this. So you can write that out if you want to. I choose not to. So the antiderivative of f prime is f. The 2 does nothing. He's a scalar. You could ignore him. And then the antiderivative of 4 is 4x. And so then I'm going to plug in the 5. Then I'm going to subtract, and then I plug in the 3. And so this is what it looks like. It's important to note that our result has a plus sign. So when you do minus, make sure you have the parentheses on there so that the minus sign distributes to both of those. F of 5 is really easy to see. It's a 0. So when I do that, it just goes away. Then I have 4 times 5, which is 20. And then I'm going to go ahead and distribute the negative so I don't mess things up. 4 times 3 is 12. So now I have 20 minus 12, which gives me 8. And now I need to know what f of 3 is. And here, guys, I'm not going to lie, I paused for a second. I was like, oh, dang, this looks like a lot of work. In order to know that point for 3, at 3, I'm going to need to know the rule for this curve. Now, I know that it's a circle, and I know that the center is 5, 3, so I thought, oh, dang, so I am able to write the expression for that. But then I started thinking that's way too much work in algebra for a calculus test. There's no way. College Board usually doesn't have you do something this deep into Algebra 1. I reviewed the directions and realized, oh, that's right. They gave me the value at 3, which is 3 minus rad 5. And so 3 minus rad 5 is what I'm going to put in there for f of 3. I distribute the 2, then simplify. I get 2 plus 2 rad 5, which is the correct result. Now let's take a look at C. Give ourselves some room right here. C says the function g is given by this, negative 2 to x, and f of t is my integrand. Find the absolute maximum value of g on the interval from negative 2 to 5. Justify your answer. Now, if we're trying to find an absolute max, we're going to need to test the endpoints. And then you're going to test the critical values of g. So to find our critical values of g, we need to know what g prime is. Now, we know that g prime is f. So we just need to know where f is either equal to 0 or undefined. And so looking at the graph of f right here, I can clearly see that f is defined everywhere. There's no holes or anything like that. But it does, and it does have, so it's defined everywhere, so that means does not exist anywhere. But there are some points where it does equal 0. And we find that it equals 0, f equals 0 at negative 1, because that's an x-intercept, and at 1/2. And so we're going to have to test those two. Now, one of these you could eliminate right away because we're looking for the absolute max. And I see that for 1/2, we are below the axis, then above the x-axis. That means this is going to be where a relative minimum is for g. So I technically don't have to test 1/2. But I think when I first wrote that, I wasn't thinking of that, but you could and eliminate 1/2 and not have to do it. But let's go ahead and find out what g of negative 2 is. Oh, and we have 5, but 5 is also an end value, an end point. And so I didn't need to write it right there, but it is technically a critical value. Okay, so and g of 5 was found earlier. So I just went back and wrote that down. It was found earlier in, I think it was the work that we did for part A. So g of negative 1 is 1/2. And then actually when you do try to find g of 1/2, you're going from negative 2 to 1/2. And if I'm thinking about that, negative 2 to 1/2, I know that this area is bigger than this area right here, so I know this is going to be a negative number. So I don't even do all the work to find that value. I just know it's negative, and I'm looking for an absolute max. 0 is greater than that, so he automatically gets eliminated. Now, 1/2 is greater than 0, so 1/2 could be the max. I'm not quite sure what this is, but I'm pretty sure that's going to be more than 1/2. And so I think I found my max, but I'm going to clarify, double check, make sure that that is more than 1/2. And so this is the work that I ended up doing. I went 8 divided by 4, and I divided that by 4, and so I get 2 minus sorry, not minus, plus the 9. So 8 divided by 4 is 2. Now I'm going to add 9 to it, so I wrote that. And then I have negative 9 pi over 4, so I have that right there. This simplifies to 11, 9 pi over 4. And if we do some rough estimating, check this out. Pi is the same as 3.14, so 9 times 3 is 27. And 27 is actually really close to 28, which is divisible by 4. And if you went 28 divided by 4, you'd get 7. And 11 minus 7 would be 4, which is clearly bigger than 1/2. So this must be our maximum. So I'm going to write that out. 11 minus 9 pi over 4 is our absolute maximum, and that's our final answer for letter C. Last, we have D, and D is having us find the limit of this nasty-looking thing. So really quickly, our first attempt to solve a limit is always to use direct substitution. So let's go ahead and plug in this 1 to all our x values. This is what we get. We get 10 raised to the 1 power minus 3 f prime of 1. And on the bottom, we have f of 1 minus arctangent of 1. We have 10 raised to the 1, which is just 1. And then we have 3 times f prime of 1. F prime of 1 is the slope of f at 1. So if I look at 1 right here, I see right there, what is the slope right there? And to find that, we just have to count the rise. 1, 2, 1. 1, 2, 1. We count the rise and the run. And so we have found the slope of this line to be just simply 2. So we're going to multiply that 3 by 2 and get 6. So we have 10 minus 6 up top. And on the bottom, we have 1 minus power of 4. Now, you might have forgotten for arctangent where tangent equals 1. Because this is the question you're asking yourself. What theta will give you a positive 1? Now, arctangent has a range of from negative pi over 2 to pi over 2. That's its range. All of the answers for arctangent can be found in quadrants 1 and 2. And that narrows down what thetas we're going to put into tangent to give us a 1. We have to be in the first quadrant because tangent is negative in the fourth quadrant. And there's only one angle in that quadrant that has the same x and y values, so that when you divide them, you get 1. You need to have the same sign and the same cosine to divide and get 1. And we know that that is at pi over 4. It's right in the middle of that quadrant. So that's how I found pi over 4. And then with a little bit more simplification, we have 4 divided by 1 minus pi over 4. And here is your scoring guide, just in case you were curious about all the points. That's the end of this FRQ.